saying, but wouldn't all those past experiences and your current environment, despite the fact that if you're introducing an element of chaos so that you've never experienced this ever before, your experiences that you have had would then inform your decision about the thing that you've never experienced.
Does it
rather
inform
than
or dictate?
predicate. Right.
Or require. Right, that's the thing there. Yeah. Let's say you're in a room with a whole bunch of audience members. You tell a joke.
Right.
It falls flat. In that moment, you have many things you could do to turn it into a laugh point.
True.
Right? You hear silence, and you'd be like, "Oh, that was good," and then everyone laughs. Or so you make some
Or
sort of
is this
comment.
mic on? That's
right.
the old one.
Right.
What do you do? Do you have the freedom to choose one of several choices that you had designed from your past, that you prepared to deal with that eventuality? Or is the choice made for you already?
So why does a mind built from cause and effect machinery feel the lift of choice exactly when physics seems to tighten its grip? We're told the universe is lawful. Gravity doesn't forget to act on Tuesdays. Light doesn't negotiate its speed with your mood. With enough information, a perfectly calculating intellect, Laplace's imagined demon, could read the present and write the future. Yet, our living experience disobeys the vibe of that story. At the instant you're about to act, it feels like multiple futures are genuinely available. You can trace this tension all the way from a double pendulum on a lab bench to the jet stream of Jupiter. Those systems follow precise equations, but a hair's breadth difference in initial conditions yields a storm of different outcomes. The laws don't go away, but predictability does. That gap, lawful yet unforeseeable, is where human choice begins to feel less like a ghost and more like a weather pattern, emergent, structured, and sensitive to details you don't consciously track. Push deeper, and the details get smaller than hair's breadth. At quantum scales, outcomes aren't just sensitive, they're genuinely probabilistic. The seeds of today's galaxies were once quantum jitters, stretched across space by an early burst of expansion. Every spiral you've ever admired owes its existence to an ancient roll of the dice. But randomness isn't freedom, it's just noise. If your decision comes from a coin flip hiding in your neurons, that doesn't make it yours. The interesting move is that biology doesn't flee noise, it recruits it. Neurons sit near thresholds where a whisper of thermal fluctuation can tip the balance. In some sensory systems, a single photon can nudge a receptor. Signal plus noise can outperform signal alone, a phenomenon engineers call stochastic resonance. Brains evolved not only to tolerate uncertainty but to harvest it, pushing exploratory behavior, broadening the search through possible actions, increasing the chance that a new situation has a workable response. That isn't a surrender to chance, it's the cultivation of useful unpredictability inside a lawful machine. What guides that exploration is not blank spontaneity, but a hierarchy of expectations. Priors learned from life. Your brain is constantly predicting what you'll see next when you turn your head, how your hand will feel when it grips the doorknob, whether that person will laugh at your line. When predictions succeed, the brain banks them. When they fail, it rewires. The arrow of time and thermodynamics, the general drift from order to disorder, shows up here as well. Learning isn't a reversal of that arrow, but a local, non-equilibrium carve-out, a pocket of organized structure maintained by consuming free energy and exporting entropy as it reduces surprise. In cosmology, we measure the universe by comparing data to models and updating parameters until the residuals stop shouting at us. Your brain runs a close analog at biological speed, probabilistic prediction and error correction that often approximates Bayesian updating. That gives you options that are neither arbitrary nor prescripted. They're moves proposed by a model that has been shaped by the world and that keeps reshaping itself as the world pushes back. The tension persists, though. If the model writes the action and the world writes the model, where do you enter the loop? We usually enter it at the level of control. Physics is fine-grained, life works at a coarser scale. Temperature is real, even though no single molecule has it. Pressure steers weather systems, though it's a macro quantity. In science, we call these effective descriptions. They aren't fake. They're how reality organizes itself hierarchically. Agency lives there. You can fire a thruster and put a spacecraft on a new trajectory without talking to its atoms. You exploit regularities the way navigators exploit currents and gravity assists. precise laws upstairs, useful levers downstairs. Likewise, your brain-body system forms a feedback loop with the environment. Sensors feed predictions, actions test them, corrections happen. Over time, this loop carves out a controllable subspace of the world, things you can reliably influence. The stronger that loop, the more the future depends on your internal state rather than on outside whims. If you've ever watched a gravitational slingshot around a planet turn a tiny burn into a massive course change, you've seen how small inputs, timed well, can leverage big dynamics. In cognitive terms, practice tunes your internal timing. The same laws, different leverage, zoom out to the largest canvas, space-time itself. Relativity gives us a four-dimensional picture where past and future sit together in a geometric whole. It's tempting to declare that the future is as fixed as a mountain range, but physics doesn't mandate that perspective as the only meaningful one. When you solve a complicated system, you choose a representation that exposes the causal handles you can actually grab. In quantum field theory, we renormalize, systematically integrating out high-energy fluctuations and redefining parameters so the theory makes finite, scale-stable predictions. With black holes, we trade intractable interiors for surface quantities that encode everything you can learn from the outside. Holography suggests the information you need isn't everywhere. It's organized at boundaries. Minds have boundaries too, the interface where your predictions meet reality. At that boundary, the relevant variables aren't quarks and photons, they're beliefs, goals, habits, and skills. The macroscopic coordinates that determine which actions are viable next steps. Your sense of freedom is tied to how many of those actions you can credibly make work given your learned model and the energy you can spend to push the world your way. So, why does a mind built from causes feel like it could have done otherwise? Because at the level where minds operate, otherwise is real, not as magic that breaks laws, and not as a lottery that ignores them, but as a repertoire of lawful, learnable trajectories through a landscape of constraints. Chaos ensures that tiny differences in your internal state, the timing of spikes, the posture of a plan, can direct the system down distinct, stable paths. Intrinsic biophysical noise, thermal fluctuations, stochastic ion channel gating, and probabilistic synaptic release provides the raw variability that biology shapes into exploration. Thermodynamics rewards organisms that use energy to maintain and update predictive structure, expanding the space of actions that will likely succeed. And emergence grants us a language where the causes that matter are goals and models, not molecules. Within that frame, having freedom is not being uncaused. It's being the cause at the right scale. The choice that feels open is the moment your model judges multiple futures as controllable. You could have done otherwise because across time you built a brain that can make otherwise work. The laws of nature don't pre-write that capacity. They allow it, and minds, through learning, author it. Like if this was interesting and hit the subscribe for more.